Next example, we're actually given the first few terms of a Maclaurin series and also the general term. And we're asked to find two values, f prime of 0 and also the 10th derivative of f evaluated at 0. Okay. Well, we want to set this up with our Maclaurin template, if you will. So we know in general that a Maclaurin series will be f of 0 plus f prime of 0 times x plus f double prime of 0 over 2, or factorial, times x squared, plus so on and so forth, all right, until we have our nth term, which is the nth derivative evaluated at 0 over n factorial times x to the nth. Okay, so with that in mind, finding f prime of 0 is actually rather quick. We can do that right away. We know that f prime of 0 is the coefficient of our x term, and we can see our x term right here. Linear term is 1/2 x, so f prime of 0 will just be 1/2. Right? What's a little more complicated is what's our 10th derivative of f. Right? Now what we don't want to do here is actually expand this out and then take 10 derivatives. Okay, that can be done that way, but that's too much time. Let's use the template. All right, so if we're interested in the 10th derivative of the function, all right, well, that's part of the coefficient of the x to the 10th term. So let's write that real quick, all right? The 10th derivative of f evaluated at 0 over 10 factorial is, times x to the 10th. All right, that's our term that includes the 10th derivative of f at x equals 0. All right, now let's think about that. What would that actually be equal to? All right, well, if we go up here to the actual series, if we plug in 10 for x, because for n rather, because we want x to the 10th power, so n is going to be 10. That means we're going to have x to the 10th over 10 plus 1, or 11 factorial. All right, so the 10th derivative of f evaluated at 0 divided by 10 factorial of x to the 10th, that's our general term, and then this is the term that's specific for our series, that's for the 10th degree. So we basically realize here we don't need the x to the 10ths. We need this equation to be true, all right? So what do we need to do in order to solve for the 10th derivative of f? We got to get the 10 factorial over to the other side. And we can do that very quickly by multiplying both sides by 10 factorial. So what you end up having is the 10th derivative of f at 0, oops, we no longer need that, is equal to 10 factorial over 11 factorial. And we know that 11 factorial is 11 times 10 factorial. So we actually have just 1 over 11 as our answer for the 10th derivative of f evaluated at 0. All right. So that's a little more complicated. You may want to watch this part of the video another time if you didn't quite get it the first time around. But ultimately the idea is match the general 10th term, or x to the 10th term, with the specific x to the 10th term for that Maclaurin series, and then see what the 10th derivative of f has to be.